Good morning,
Hi,
everyone.
Chandra. Good morning. How are you, Chandra?
I'm fine. Greetings from Berlin, Germany, by the way. It's a bit more early here, but yeah, I'm so happy being
Oh,
here.
was the time there, Sandra?
Uh, it's 8:20, so
Okay. That's pretty early.
a bit. It's fine. For
Yeah.
Germans, we are used to get up early, but yeah, still.
So how are you doing?
I'm great. How are you?
I'm doing good. So, Sandra, right now we had Srinivasa as the first speaker for J Cloud Day. Next is you. So, uh, really thankful to have you as a speaker. I I would give a quick intro about Sandra. So, guys, Sandra is from Microsoft and she is part of the developer advocacy team for Java. So, Sandra, I would request you to give a quick intro about yourself, what you're doing, and what is your session going to be about today.
Yeah, sure. Let me just share my screen, then I can go right ahead
Sure.
with my presentation. So my name is Sandra Algrim. I'm here from Berlin, Germany, as we already said. And I'm a cloud advocate at Microsoft. I focus on Java on Azure. So if you're from the community, if you're doing something for the community, you can totally reach out to me and we do something awesome, fun together. And you can also find and follow me on Twitter at @screamhit, or as I said, I'm Sandra Algrim for LinkedIn. And today we're going to talk about Go Serverless with Java and Azure Functions. So for that, we're going to start with the evolution of application platforms. First, we've all been on-prem, where we had our servers right behind us in another room or in the cellar if we had more servers. And there we need to care about all those things. How do I deploy new code to my server? Who's monitoring my apps? Who has physical access to my servers and who monitors my servers, as well as everything comes up with my apps. So what OS should I use? What needs to be installed in order to make run my app smoothly, and everything like this. I even had to take care about electricity, like what shall I do if there is a power outage, and all those kind of things. Then we went a bit better and used things like infrastructure as a server. There we still had almost same questions, but they were a bit more, bundled. So I had a department or another company who took care about how often should I patch my servers, and is the electricity there, and yeah, all the other questions as well. How many servers do I need? And obviously, there are still the questions about my deployment. So how do I deploy new code to my servers, and which OS should I use, and who is monitoring my apps? Going on from this one, we went to platform as a service. And there we had the questions only like, what is the right size of servers for my business needs? And servers is there with those hypothesizes, as you also could use VMs or containers or whatever. And how many servers do I need, and how can I scale my app, and even how can I utilize or increase my uses of these containers. And the next step is obviously serverless. So there I can really focus, how do I architect my app? Because everything server related is taken care of already. I don't mind which OS is running, as I will only focus on my app, on my code, and make it just work and then ship it to production. However, it will just work. So serverless is the platform for cloud native apps. Again, what is serverless? We have the abstraction of servers, as I already said, and we are event-driven and on instant scale, meaning I have an event and then I can just scale up on this event, saying we have Black Friday, the traffic is increased largely, so I can just instant scale my code, my functions, my apps, and it will just work. As well as we do have micro billing, which is awesome, because giving that example with Black Friday, I will have a higher usage of the cloud, so I will have to pay more, but as I have higher usage of my app, I will probably also make more revenue and more money, so I can keep up the cost for the infrastructure as well. But it's also working the other way around, right? So if parts of my app is not used so widely any longer, no worries. At least I don't have to pay that much for my infrastructure any longer, or for my servers or whatever, because, I don't care, as we are serverless. So summing up the benefits, I can really focus on solving my business problems. I don't care about the technology OS. That brings me more efficiency. I have shorter time to market. I have better service stability because, someone else is taking care of my infrastructure. I have better development and testing management, and also important, as we're still, trying to be more green for our environment, we also do have less waste, as we don't need to to have many servers in our infrastructure, and we also don't have unused hardware that much. And we are very more flexible, so I can easier experiment on it. I just try something out with no cost beforehand. I can just do it. We will do it later in my demo as well. And it's therefore also a natural fit for microservices. So let's have a short look at Azure Serverless Platform components. As I said, we do have the Azure Functions. That's also the one I want to demo today. There you can execute your code based on events you specify. We're going to see what events those could be later. And then we do have logic apps. Those are to design workflows and orchestrate processes, among functions and also other Azure services. And there's also something to manage all events that can trigger code or logic. Those are the event grids. We don't go into that in detail today, but I'm going to provide you some documentation where you can, find out by yourself. And those are all bundled in our platform with databases, storage, security, and so on. And it's definitely probably the most best integrated with development suites. So we have the best IDE support, you have integrated DevOps, you can develop locally with visual debug history, and you have monitoring right in place. So let's go right ahead with Azure Functions. As we already said, it's code triggered by events, and this is gonna boost your development efficiency. And that's also, by the way, how our logo comes from, or where our logo comes from. So I said we have different events. So those can be triggers. There you can just use triggers to define how functions are invoked. And this one we're gonna see later on with an HTTP trigger. And then we also do have bindings, so you can also connect your third-party services or Azure solutions like databases. That's also another demo we're going to do later. And there are even other things like proxies or CI/CD, which is in place, and also the monitoring we talked about. And what I love also is the local debugging. So you don't even need the cloud to just see if something is working, and you can even debug locally your function and connect it to the service in the cloud. So that's also working. So let's go right ahead with the first demo. So here's my Visual Studio Code. I hope everything is big enough that you can see. So I have the Azure plugin installed, and as well as the Azure Functions plugins. Those are the two you will need to do my demo, as well as the Java extension. So I just click on New Function, and I say I want to use Java, and I give it a name like a JCloud function, a JCloud.conf, for JCloud.conf. It's a snapshot. So, and as I said, the integration with the IDE is just perfect. So that's why it will just generate everything for me. Oh, and it's already finished. So I can probably already see the code. Yeah, there we go. So what we can see here is a normal Java project. I do have a POM XML where I can see that I'm on Java 8 right now. You can also use Java 11, but therefore you would have to do it via the portal, or you download an example from GitHub and then uploaded it here via Visual Studio Code. And I also have the dependencies for Azure Functions here, as well as the test dependencies, because also the tests are generated. So here I do have my HTTP example. You can see here that it is an HTTP trigger by request. You have the methods get and post. Everyone can use it. It's anonymous. You could also specify here another authorization level. But for this short test and example, that's one should be all you need here. And I can even have a logger, which is very useful for local testing and debuggers. And here I just pass a query name, and then I could see hello and name. So what I can do here, can just start debugging and run this function locally. We also run the tests. And what you see here is a bit kind of a cold start. So if I do it the next time, it will be way more fast. And that's kind of the same you will experience also in the cloud. But in the cloud, obviously, the hardware is probably better than on my local machine here. So it's a bit faster still. So here I have the link. I can go on now. There we go. So it says, please pass name a string. And as we specified, and say name cloud.
Sandra, sorry to interrupt you. Could you please increase the size?
Even more?
Yeah. Yes, now it's good.
Okay. So I just passed the query string that might be a bit small here. Sorry for that. Okay. So I can see here hello jcloud or Sandra or whatever you want to see here. Thanks for the feedback. 8. So, and we could also do a breakpoint. And yeah, as we said, we also have a logger here, so I can also see all the request details here. Is that big enough, or should it be still bigger?
Sandra, this one as well, because people are not able to see.
Sorry, I didn't got it.
Yeah, so participants are not able to see the font.
You can't see Visual Studio Code, or is it too small?
This one, the Studio Code.
This one is what?
The Studio Code, the people are not able to see. So could you increase the size?
Yeah, sure.
Yeah, sure. Yeah, they should be. Thanks.
All right, perfect. Thanks for saying that. Otherwise, it's just useless. So again, we do have the HTTP example here, which can be triggered by an HTTP trigger, and then gives me a logger even. And here I have my answer. That's why we saw here the hello and the name thing, which I passed already here. All right. And no worries. This one was all generated. So if you're following the exact same steps, you will have the exact same outcome. So you can just try that by yourself afterwards. So let's talk a bit about Azure Cosmos DB. I would not go into too much detail here because we don't have so much time, but no worries. I provide you with a great link to another resource for it to have it more in detail. Everything you need to know is that it's a NoSQL database. So you have an elastic scale out of storage throughput. You also have guaranteed low latency, and we also have well-defined consistency models. As I said, it's NoSQL, so we have a key value store. You can use column family, you can even use GraphQL or document storage. And what's the best about Cosmos DB, in my opinion, is that it's working with different APIs. So you could just stay with your MongoDB if you have that in place, or you go with SQL and Azure or Cassandra. But this time we're gonna look more into the SQL part, as we just announced that you could also use Azure Cosmos DB serverless, so you only pay for what you use. But as it is still in preview, it's only for SQL enabled. Yeah. And as I said, Azure Cosmos DB is fully managed, it's globally distributed, it's turnkey, it's designed for massive scale, and it's guaranteed low latency. So it's perfect for our serverless environment and for the testings here. And then in order to create and add a Cosmos DB, I will just go on my Azure portal. Can you see that, or should I do this live as well because it's too small? Okay, I assume you can see it if nobody's answering. So I just go here and search for Azure Cosmos DB. I choose my subscription over here, specify a resource group, and give it a name. And because we want to use the serverless preview model, we can only go with the core SQL API. And I also recommend only use it for non-production, as I said, it's only in preview. So don't go ahead and just put it into production. But as we said, we just want to test and try things out. That's the perfect example for it. And after we initialized and did our deployment, we will also have to add a collection here to use that later in our Azure function. This one was pre-recorded because otherwise we would have to wait here for 5 to 6 minutes. So I shortened that up a little bit. Yeah. And then I can go to the resource, and it's just going with the quick start. And here I can either just click on create an items container, or I go with the data explorer. And once it's connected, I can see here the to-do list. That was the items container I just created by clicking on this button. And I will just create a new container with a new database ID, which is going to be like my database. Container, and just call it my container. And partition key is very important. That's the logical resource where you can find your key values in the data, which can also be in the JSON format. So, perfect. Should be created shortly. There we go. And now I can see here my items, which I just created. Great. So let's go in and change our functions a little bit, because this one was an HTTP example with an HTTP trigger. And now what I want to do is just copy paste another example, which is probably the most simple version of a Cosmos DB processor. It's a Cosmos DB trigger, and it's triggered by items. So whenever I do a change in the items collection I just created, it will log that here in my functions app. So it's really super simple, not really real world use case, but you can use that and go ahead and go on with that one. Okay. So what I also need to do to make it work is, as I don't, usually you should, adapt the test and do it again, but that should be fine. And I also need to specify the local settings JSON obviously it has to be connected to my database in place. So just copy it here. So I will use development storage and then add here my database with the secret connection string, and I'm using the functions worker runtime Java. So I have that in place. I can go ahead and run this function as well. And in the meantime, let's go to my Azure portal. And go to the Cosmos DB. There we've talked about the Data Explorer. I hope it's big enough. And here would be my database with the items. And if I create a new item here, which is gonna be 1, 2, 3, 4, 5, and save it, I should be able to see it in my function. Yeah, there we go. So that was really fast. And yeah, here's the item I just created in the functions DB. So that was really quick and awesome. You can just go on from this. You can do like almost everything with functions. You could also, write a function which would enter the entry in my Cosmos DB. So it also enables me to go maybe from big monolithic applications towards microservices, because I could just create a function which is probably listening at one SQL, probably the MS SQL or whatever I used in my monolithic application first, and then watch there the entries, and then put it into a NoSQL database and go on from there with another function which might do something with the event, like deserialize or use machine learning to get even more out of my data here. So I'd love to talk even more about it, but I think my timing is running. So yeah. What is Azure Functions? Again, it's the best of function as a service. You have the integrated programming model. You have the enhanced development experience. And by the way, if I want to publish this one to Azure, it's just another click from the portal. I could just go here and upload my function, the one I just created, and then it's uploaded there. So it's really easy and very awesome. And I also have the flexibility in choosing the hosting option. If I create a new function, on the portal, I have to select if I want to go on Linux or Windows, but actually I don't care, because it's not worth the thought, because everything is working exactly the same way. So serverless is enabling me to focus on code, not on plumbing. I have no infrastructure management here. I can auto-scale based on my workload, and I don't waste resources because I only pay for what I use. And also for the environment, we only need to spin up what customers and what we all are using. Functions as a service programming is at the center of serverless. So you keep in mind that you should follow the single responsibility principle. So every function should just have one single responsibility. If you need more, then you have more functions, and you connect them via logic apps or via other triggers. And they are short-lived. So usually a function has just one purpose, like copying data from one database to another, or other examples, maybe get the temperature of my IoT device and just put it into an event grid or into another storage. So, and then it's gone. There's no state in my function. So all functions should be stateless, because they can't hold any persistent state. And that enables them to be event-driven and scalable. So they do respond to predefined events. They're instantly replicated when you have more events. So at any time you need them, we can just scale them up and down if you don't need them any longer. So that brings me to your homework. you can just go. I said you always go as with the payment as you need it, but everything I showed, you can even have it for free. You can just click on it, and because you can have 5 GB of Cosmos DB for free, and Azure Functions are also free until you reach a certain level. And so just go ahead with your side project and do that. And there's also the documentation for Azure Functions. So if you want to create a short Azure Functions, not everything is generated automatically as we had it here. So go here, and there's even a more complex example, which is under AKS/MS/homework. I totally invite you all to do that. It's gonna connect your event with Azure Functions and Cosmos DB. So you're already set up. You probably have this idea in mind you always want to do. Just do that. It's super simple here. You can probably achieve that. And if you need any help there, go connect with me and we can do that together. And if you did it, put it on GitHub and send it to me on Twitter, then I can cheer for you and look at it. And yeah, I'm really looking forward to your thoughts and how it's going for you. Thank you very much.